Infiltration is the process by which surface water enters the soil. The infiltration rate is a measure of the rate at which a soil is able to absorb surface water inputs such as rain or snowmelt. The infiltration rate varies as soils become increasingly saturated with water, reaching a minimum when the soil is saturated. Infiltration rate is expressed as Ksat, or saturated hydraulic conductivity, which is the minimum infiltration rate estimated from field measurements. Disc permeameters create a negative potential or tension to exclude preferential flow in macropores, producing results that reflect only the influence of the soil matrix. Disc permeameters measure hydraulic conductivity on the soil surface, effectively giving an accurate measurement of Ksat unbiased by macropore effects, which are likely to be highly variable depending on where the infiltration trials are conducted. These instruments minimize the sampling biases that may be introduced with ring infiltrometers. Necessary equipment for infiltration analysis includes 1 large disc permeameter, clean silica sand, data sheets or a field notebook, a stopwatch, a 5-gallon bucket of clean water, a ruler, and access to Microsoft Excel. Field analysis of saturated hydraulic conductivity or infiltration rate through large disc permeameters is easy. When all preparation steps are complete, one just needs a stopwatch, data sheets or a field notebook, and the large disc permeameter. First, measure the storage tube and disc's interior diameter. These measurements will later be incorporated into the infiltration calculations. In this example, the large disc's permeameter storage tube has an interior diameter of 4.4 centimeters, and the large disc has a diameter of 22 centimeters. Ensure the data sheet has been properly labeled with the radius of the ring and the area of the ring. Remember, area measurements are calculated through pi r squared. The data sheets are available on the Ecohydrology webpage through WebCT. Before any infiltration analyses or trials are to begin, the soil texture shall be determined for the field area. Techniques behind soil texture class analysis can be found on the video titled Soil Texture Analysis using the field method within this video series. Properly label the texture on the datasheet and choose the appropriate theta and n values for the soil texture. These constants will later be used for the infiltration rate and saturated hydraulic conductivity determination. Once the soil texture has been determined, adjust the suction on the Marriott tube of the permeameter. Suction can be seen and measured as the difference between the inlet tube on the Marriott and the upper inlet tubes. Typically, sandier soils should have a larger suction. If unsure of which suction to initially use, start with a suction or tension of 3 centimeters on sandy soils and a suction of 1 centimeter on all other soils. Appropriately label the initial suction on the datasheet. And remember that this initial suction can easily be changed. If the water level leaves the storage tube at a quick rate without arriving at steady state, then increase the suction. If the water level slowly leaves the storage without significant changes seen in the change of volume of water between time intervals, then the suction should be reduced. Now that the initial suction has been extrapolated from the soil texture, the site should be prepared. Take care not to disturb the outer fabric of the disc. It is recommended to place a towel below the permeameter when not in use. The permeameter should be placed on a level surface before infiltration analysis. Use silica sand to create a level ground surface, and take care to use no more than 1/2 inch of the sand. The ground surface level can initially be tested with the bubble level on the permeameter. When the site has been leveled, the permeameter is now ready to be filled with water. Remove all plugs of the permeameter and place in the 5-gallon bucket filled with water. Then securely put the plug back onto the permeameter storage tube, open the clamp, and either use a pump or suck the water up with your mouth to the top of the storage tube. Reseal the clamp and ensure the water level is steady and remains near the top of the storage tube. Now, remove the cap of the Marriott tube and fill water to the top of the tube. Recap the Marriott tube and ensure the suction tube is clamped. Before the infiltration trial is to begin, note the initial water level on the storage tube and note on the data sheet. The infiltration analysis is now ready to begin. Place the permeameter onto the level ground. Immediately start the stopwatch and at the pre-established time intervals, note the water level. The volume of water input into the soil column should also be noted at each time interval. The volume can be calculated as the change in height of water as noted on the storage tube, multiplied by the interior surface area of the storage tube. In this case, the surface area of the tube is 15.21 square centimeters. So, the delta H, or the change in the height of water on the tube, is multiplied by 15.21 for the volumetric measurement. This would simply be the previous row's height of water subtracted from the current row's height of water, multiplied by the interior surface area of the storage tube, or 15.21. Measurements shall be taken and noted until steady state is reached. Steady state can be seen on the tail of this chart and can be assumed in field when the volume of water per time interval becomes equal or similar for subsequent measurements. Normally, a two-step process derived from the works of Zhang, Carcel, and Van Ganuchin is utilized for infiltration analyses with large disk permeameters. It applies a correction factor to initial estimates of saturated hydraulic conductivity to account for the amount of suction, the disk radius, and specific soil texture qualities. Please note, two different equations are used depending on the value of the constant N. A pre-formatted Excel spreadsheet is available on the Ecohydrology webpage through WebCT. It just necessitates the input of the disk and rings radius, the height of the water measurements at each time step, and a slope calculation. If one chooses to create a new spreadsheet, the Van Ganuchin parameterization equations and the infiltration rate equation, which all can be seen on the datasheet, must be inputted in order to arrive at C1 and A, where A is a value relating the Van Ganuchin parameters to suction rate and disk radius, and where C1 is a parameter related to hydraulic conductivity. Finally, as the datasheets show, K equals C1 over A. While A is found from the previously seen equation, C1 is garnered through the finding the slope of a graph of the square root of time plotted against infiltration. This is a graph plotting the square root of time against infiltration. Infiltration is found by first arriving at cumulative volume and dividing this by the area of the disk. Cumulative volume is the total volume of water which has entered the soil column. The square root of time is simply the square root of the cumulative time steps. Finally, the slope is found by applying the linear equation y equals mx plus b to the trend of the data, where m equals the slope and also equals c1. In this case, c1 equals 5 times 10 to the negative fifth. Once c1 and a are found, k can easily be arrived at by dividing c1 by a. In this example, k is 5.34 times 10 to the negative fifth. While this seems like a small number, it is in meters per second. If this is transformed into centimeters per hour, one arrives at 19.22 centimeters per hour.